So, I hope you are able to hear me. Pratap, Sarukesh, Varshita, Ivan, Ahanashri, Hanishika, Dishita, Ananya. I hope I am audible to you.
Yes, sir.
Okay. So, Hanishika, online class means the video has to be on. Ahanashri, the same follows to you also. For the online class, video should not go off. Please don't forget that. And we'll start the class in 2 minutes. But before I go into the topic and the people are joining yet, let me just discuss the plans of the coming days, because we are almost nearing the completion of volume 1, and how the things are going to go in volume 2, what is the plan, how we are going to make you ready for the board examination. All these things I want to discuss with you. So, see, I don't know how much you are fearing about the board examination. I am not fearing, but I am worried about you people, because you are going to face the board exam this year and get a feedback from your seniors last year. Board exam is not easy. Board exam is something which is challenging, and if you don't focus from the beginning, it becomes difficult day by day. And still, if you are not serious, then you will have a very tough time at the end, and then the efforts will not convert results. So, please become serious if you have not become serious till now, because this year is going to be a very, very, very important year for you. Now you may not be feeling it. Another 2 months will happen, no? When October comes, when the school starts their half yearly examination, full portion mock test, then you will start realizing that I am behind and then no place to cope up, right? So, the first instruction that I want to give to everybody of you is become serious. If you are not, become very, very serious. I know some of you are working hard and marks is not coming into place, but don't worry about that. If you are working hard and mark is not coming today, no worries, mark will come one day, very soon. But if you are not working hard and mark is not coming, then it is the point of worry only. If you are putting your efforts, if you are giving your best and you are getting a average result, then there is no worries, because I know a time will come, another 2-3 months, you will start getting good marks, and at the end you will have 95, 96 plus marks in the board examination. But if you are not working hard at all and then you are not getting the marks, that is obvious, because without working hard, you cannot expect the marks to come in the examination. That is the truth. So, please make sure that, sit here man, please make sure that you are giving your best, if not till now, at least hereafter, because don't take it lightly, especially the physics examination. Physics examination can check your knowledge to the core. Just by knowing some things, you cannot go and write the board examination. After that, you have NEET and JEE also this year. So, be serious about your future. This is the last time you want to correct yourself. Second important thing I want to speak to you is about the plans that I have for you. So, as we are nearing the completion of Sharan Ram, no place, where are you going? You have to come in front only. Fast, please. Yeah. So, as we are nearing the end of volume 1, today is the last class. Most of it I will finish, and we are going to go to ray optics from tomorrow, next class I mean. So, volume 2 after ray optics will become very fast. That is, very small chapters are remaining. The major chunk of physics we have completed. Believe me, 70% of syllabus we are done. Good thing or bad thing, 70% of marks we have not covered. It means even after learning 70% of the whole physics, the weightage it has is not 70%. Why I am saying it is a good thing for you? Because volume 2 is easy and volume 2 has marks also. So, they have made the syllabus in such a way that even if you are little weak, you will be able to pass. For that only we have volume 2. Atom, nuclei, semiconductor, dual nature. I can tell you this question will come, and that will only come. And you, if you are a decent student who do what I say, you will be able to score marks there. What twists and turns can happen, what can trouble you is volume 1. And if volume 1 you are okay, no sir, I am okay with everything, electric field and charge, capacitors, current, magnetic effect, magnetism, EMI, AC. If you are good in all these things, then you are going to score 95 plus only in the board examination. Volume 2 is going to be easy. That's why I am confidently saying that by next month end, if I keep some extra classes, I will be able to cover the portions of full physics. And that is what my target is. My target is before October, mid. My target is September end itself. It will be difficult actually, but I will try. We will finish syllabus, not because I have a hurry of finishing syllabus, because I want you to have a practice of the board examination. And I want everybody who is sitting here to have enough tests in front of you which will guide you to understand the questions can be twisted in how many different ways. So the plan goes like, from October first week or maximum by second week, you will be starting your test series here. When I say test series, this time we are planning to keep 4 months of test series. Never we have done this in past. This is the first year in last 8 years of our running. We are going to have 4 months of test series, October, November, December, January, test only. Every week you will have 3 tests and every week you will have 3 discussion classes. So Monday, Wednesday, Friday if it is test, Tuesday, Thursday, Saturday will be discussion. Initially for 1 month we will give you chapter wise test. I will divide the whole physics into 4 parts and I will ask first 5 chapters, the next 5 chapters, like that I will ask. Next month, November month, you will have mark wise test. One day will have only MCQs. One day will have only A and R. Only A and R. You will fail in the test. But only A and R will be there. Then you will have one day 2 mark alone. One day only 5 mark. One day only case study. That test will be there where you will be getting training specifically for a particular type of questions. Vaishnav here. No other placement, that's why. So the only after that, that is when December starts, mid of December, we will be having full mock test. There you will have the full portion test of 3 hours. Until that we will have 2 hours test only. But beyond that we will have 3 hours test, where you will be getting at least 10 papers of full mock. That is physics, 10 full length mock test you will write. And one thing I am going to mention here, as we proceed, your school will also keep all these things. Your JEE exam will be knocking the door. Your board practical exam will be there. So you are going to have a tough time. But ultimately if you see, what is going to be the portions of board exam, NEET exam or JEE exam, it's not going to be much different. It is not going to be much different. So if somebody is really good, in school syllabus, I am not guaranteeing they will do very good in NEET and JEE, but definitely it will support them in NEET and JEE. And nobody can be good in NEET and JEE without being good in the school. I said that if somebody is very good in school syllabus, it will definitely support them for their NEET and JEE, support. But it is not possible that you are good in NEET and JEE and you are not knowing school. That is not impossible. If you are saying I am good in NEET and JEE, it means you are good in school also by default. So that is how things is going to unfold in the upcoming days. I hope I gave a roadmap to you. And whoever out of all, almost 50-60 of you are sitting today's class, everybody who is in the class today, if you are listening to me and if you are following this, I assure you, you will have a good result. Because now also if you are not in a mood of seriousness and you are simply coming for time pass here, stop coming. It is not going to give you anything. Because with time, we are going to become more stricter only. And with time, we are going to have more test, more discussion, more questioning on you only. And that time, if you are not scoring good marks, then that is going to be a bad time for you. Now, if you are not scoring good marks, fine, we can improve still. But during November, December month, if you are not scoring well, that is a matter of big concern. So, please have this strategy applied in whatever I have told now. Please cooperate with whatever we are doing. And come in the mind that you are going to appear for the most important exam of your life, which will decide your future. Where you will study, where you will work, and what you will do in your whole life is going to depend on the coming 6-7 months only. So, at least now, don't waste a single minute of your time. Everything, every day, every second is important. Please understand that. Okay? So, let us not waste further time and let us start today's class. Today, I have planned to teach you electromagnetic waves. That is why I have called everybody together, because now I have made both the batch to be in the same place. Very difficult, but I made it. That is the batch number 1, which is the online batch, hybrid batch, and the offline batch. They both are in the same place now. In both the place, I have finished AC. Difference is, in the last class of Wednesday, I did a question solving of AC, if I am right. I took a paper, same paper I gave yesterday, but I was not there in the class. It would have been given to, on Monday I gave the paper, I think, in the offline batch. If you have not done that, please complete it. Those who are there in the offline batch on Monday. Today, our aim is to talk about a new chapter, which is electromagnetic waves. Everybody, please give the heading as electromagnetic waves. Videos should be on. I have told so many times, if you are in the online class, the video should not go off, or else I will be forced to keep you in the waiting room. Please make sure the video should not go off. Kirtish Kumar, if you are hearing me, Kirtish Kumar, this is 12th class, man. I think you have joined for a wrong class today. You are in 11th, right?
Yes, sir.
This is 12th class. You have class only on Tuesday, Thursday and Saturday, online class. Today is Wednesday.
Okay, sir. Okay, sir.
Okay, you can drop.
Okay, sir.
Yes. So, everybody else, please make sure the video is on. We will start the class now. Okay. So, if you understand the chronology, what we have studied till now in the 12th standard, the first 2 chapters of 12th, in state board it is called as electrostatics. In CBSE it is called as electric charges and field, electrostatic potential and capacitance. In state board book, it is written as electrostatics, if I am right, right, Sai Akhilesh? You have a single chapter where you have both the syllabus together. You have, yes, 1 and 2 together, where we learnt about charge at rest. I told, if charge is at rest, it produces electric field around it. If it is a positive charge, radially outwards, negative charge, radially inwards. If it is a positive and negative charge, it has its own shape of electric field. If it is 2 plates, parallel lines, like that, based upon what is the charge, there is a shape of electric field. But static charge can produce only electric field, that you know by now. The same charge started to move. We got electrodynamics, where we learned about current electricity. We understood that if charge starts to move, charge comes in motion, it becomes current. In 4th chapter, we learnt about magnetic field. That is, current is producing a field around it. We call that field as what? Magnetic field. So, up to now, then we learned about AC and EMI. We learned 2 important things. One thing is about electric field generation. One thing is about magnetic field generation. We came to know electric field is produced by the charges at rest, and magnetic field is produced by charges in motion, because that becomes current. Okay. Electromagnetic wave. First of all, what is this electromagnetic wave and how we discovered it? The person to find this was Maxwell, and once again it was a breakthrough when he found it. If you remember, in your smaller classes, maybe in 9th standard, you studied about a chapter called as sound, if it was there in your syllabus. Many schools, they removed the chapter itself, sound chapter, COVID time. If you are not in COVID time 9th standard, then you studied sound chapter. In sound chapter, we studied about longitudinal wave and transverse wave. Do you remember that? Longitudinal wave and transverse wave? Any idea?
Sir, long wave means the wave will oscillate parallel to the its propagation. Sir, transverse waves means it oscillates perpendicular to the propagation. Sir.
Good, correctly told. Longitudinal waves are those waves where the medium of the particles, the particle of the medium, they vibrate parallel to direction of propagation. Compressions, the rare fraction. Compression, rare fraction. 11th also studied about that. And in the case of transverse wave, we have crest, trough, crest, trough, crest, trough. That is, the particles of the medium are oscillating perpendicular to direction of propagation. In smaller class, they taught to us that sound is a longitudinal wave, and many books I have seen reading that light is a transverse wave, which is actually wrong. Light is not transverse, because transverse wave as well as longitudinal wave both comes under the category of mechanical waves, and mechanical waves need medium to travel. Aware about that? Mechanical waves are those waves which needs medium to travel. Longitudinal wave travels within the medium and transverse waves travel on the medium. Like water waves, they are transverse. They are traveling on the water. Sound wave is a longitudinal wave. It is traveling within the medium. You are hearing me because the sound is traveling within the medium. If there is no medium, I will not be able to hear me itself. How much ever I shout, you will not hear me. So whether it is transverse wave or it is longitudinal wave, it needs medium to travel. Then how can light be transverse? Because light is not needing any medium to travel. Light travels from sun, comes to earth. Whether we have any medium between sun and earth? No. But it travels. Then only Maxwell thought there is some third kind of wave by which the sunlight is coming from the sun to the earth. Generally, when we talk about sun being hot and earth being hot because of sun, what we perceive, as a layman, as a child, I thought in my childhood that sun is hot, it is heating my earth, so earth is becoming hot. I know most of you, many of you will be having the same thought process, that sun being hot, heat is coming from there, so my earth is becoming hot. If I go far, since they are very far, sun is not able to reach properly, so it is cold. Like Neptune, Uranus, they are cold planets, ice planets we say them, isn't it? So our basic understanding is sun is heating the earth and earth is becoming hot. Basically it is not like that. Basically it is not that sun's heat is coming on the earth, that is a wrong thought process itself. Today you will understand all these things. So first of all, understand what is the meaning of electromagnetic waves. If there is an oscillating electric field like this, I will tell you how it is produced also. So what I have drawn in front of you is oscillating electric field. Oscillating means it is changing its direction, say positive, once again negative, positive, once again negative, positive, negative, like that. So electric field is not a constant electric field. How it is? A varying electric field, isn't it? Same way, I am drawing a varying magnetic field, but in a different direction. If you see here, if I am taking this as x-axis and this as y-axis, then this wave is in xy plane, isn't it? I can take like this, maybe in this direction. This is y, this is z, and obviously this is x. So now I am taking xz plane. Here I took which plane? xy plane. Now I am taking which plane? xz plane. So if I take xz plane, see in that way, okay, and I am drawing the wave now. Once again oscillating wave. Are you able to feel how the wave is? Don't confuse, it is in different plane, okay? This plane it is. This is magnetic field, this is electric field. Electromagnetic wave is the combination of both. It means if I am having a wave in such a way that it has oscillating electric field, it has oscillating magnetic field, and they both are perpendicular to direction of propagation, that kind of wave is called as electromagnetic wave. I will tell you how it is produced. But first understand what is the meaning of electromagnetic wave. Write down, all of you please write down. If oscillating electric field and magnetic field are perpendicular to each other. If oscillating electric field and magnetic field,
from the first sentence, sir.
I am repeating, man. If oscillating electric field and magnetic field, if oscillating electric field and magnetic field are perpendicular to each other, and also perpendicular to direction of propagation, and also perpendicular to direction of propagation, and also perpendicular to direction of propagation, then the wave is known as electromagnetic wave. Then the wave is known as electromagnetic wave. Wave is known as electromagnetic wave. You can add one more statement. Electromagnetic waves, that is EMW, needs no medium to propagate. Write that statement. Electromagnetic waves need no medium to propagate. Needs no medium to propagate. And you can draw this diagram also. First draw this diagram, then draw this diagram, then draw this diagram. This is oscillating electric field, this is oscillating magnetic field, and is clubbed together. Oscillating electric field and magnetic field, which is perpendicular to direction of propagation also. If you see the last 10 years paper, at least 2 or 3 times the question has come, draw the diagram of electromagnetic wave. For this diagram they are giving 2 marks to you. You should mention this as oscillating electric field. You should mention this one as oscillating magnetic field. This is x-axis, this is y-axis, and this one is z-axis. So a student is asking what is instantaneous velocity. That is not in this chapter, man. Instantaneous velocity is velocity at a particular instant. That is for a, suppose that you take v is equal to dx by dt. Now I am not talking to anybody of you, keep on drawing the diagram. The person who has asked, to that person I am talking. So velocity is dx by dt. If you differentiate the displacement, you get the velocity, and you put in the function the time value, then you get the velocity. So for a particular time we will have a particular value of velocity. That velocity is called as instantaneous velocity. I hope I could tell you, Mr. Aflak. Yeah, can I proceed further? I hope you have drawn this diagram. Okay. Now the question is, what is the source of this electromagnetic wave? How it has been produced and what happens exactly? I will go in more detail now. Please pay attention. If there is a charged particle, it has electric field. If charged particle is moving, it has magnetic field. Obviously, if charged particle is there, there is electric field already. If it is moving, it will have electric field plus magnetic field. But they need not to be varying, oscillating. They can be constant electric field and constant magnetic field. What I need is oscillating electric field. What I need is oscillating magnetic field. Simple. Write this somewhere. The source of electromagnetic wave is accelerating charged particle. Write that. It's a very important question which comes a lot of time in the MCQ type. What is the source of electromagnetic wave? Accelerating charged particle. So, accelerating charged particle is the source of electromagnetic wave. Accelerating charged particle is the source of electromagnetic wave. Let us understand how. Please pay attention. A charge is accelerating. It means what? Its velocity is changing. Do you agree with me? A charge is at rest. It is producing electric field. If a charge is accelerating, there are two things happening. One thing is its current value will change because current is equal to NEAVD. Drift of charged particles will produce current, and I is equal to NEAVD. If a charge is accelerated, it means its velocity will change. If its velocity is changing, its current will change. If its current is changing, magnetic field will change. Do you agree with me? So, if you make a charged particle to get accelerated, then it can produce electric field and magnetic field which are oscillating, not constant. See, if I would have made a charge to move, but with uniform motion, that is, there is no velocity, no acceleration, then also I will have electric field, then also I will have magnetic field, but they will be constant. And constant electric field, magnetic field cannot produce electromagnetic wave. What we need for that? We need a accelerating charged particle. So, the source of electromagnetic wave is what? Accelerating charged particle. So, what is happening, in the sun? Sun is made up of what? Helium, hydrogen, and the nuclear fusion reaction happening. That nuclear fusion reaction is making the charged particles to vibrate there. And these vibrating charged particles is releasing electromagnetic waves because of being accelerated. And that wave is travelling from sun to earth. And when it falls down on the earth, it comprises of electromagnetic spectrum, which I told you all to write in a tabular column. Some of you have sent me, but some of you have not sent me till now. I told you to make a tabular column, right? Remember? A tabular column demonstrating all the things, all the waves. Those spectrum, that is radio wave, microwave, gamma wave, all the waves inside the electromagnetic spectrum, they are present inside the electromagnetic wave. When it comes and hits the surface, whichever surface it is hitting, you know what is happening? Energy is getting transferred. That energy is transferred by these waves on the surface of the earth makes the objects on the earth also to start accelerating the charged particles. For example, I will tell you one thing. One very famous example is there. I have taught in 11th, those who were there. If you have apple and the apple looks red in color, why? You will say it will reflect red color light. That's what you will say, no? If you have apple and apple looks red, why it is looking red? It is absorbing all the light and reflecting red color light. If you see something black, why it is looking black? Absorbing almost everything, reflects nothing. If you see something white, why it looks white? It reflects everything, so all the 7 colors are combined to become white. That's what you think. It's true also, it's true also. But that's how you have learned your childhood, isn't it? That what is being reflected, that's the color of that object. If you are seeing something yellow, why it is yellow? It is reflecting yellow, and rest everything is absorbed inside it. If you turn on the heat, okay, and if you are heating something, it looks orangish color, orangish, reddish. Am I right? Why? Once again, you will say that because it is heated. So, what color it is emitting, that is only visible to you. The concept is, when something is given energy, energy is absorbed by it, and by that energy, it is also accelerating the charged particle of inside. For example, you know about infrared rays? We have infrared cameras installed in airports, security places. You would have seen if you are playing games also, that blue, yellow, red color light will be there, we will shoot by that, isn't it? Infrared radiations we will call it. Why it is there? We have infrared thermometers. By heat of our body, they are checking how much temperature you have. How they are making all these things? Because our body is releasing infrared waves. You know one thing, our body also releases electromagnetic waves. Why? Because we are absorbing energy from outside. Our body has electrons inside, right? Those will accelerate. It will also emit electromagnetic waves. And that electromagnetic wave you are emitting is only caught. If it is in the visible spectrum, you will have a visible color. Caught in infrared spectrum, you will have heat energy coming out. If you are having ultraviolet radiation, it will have ultraviolet radiation coming out. Are you getting what I am trying to say? When energy hits a body, the body absorbs the energy, and then the body, any object is made up of electrons, right? That is, it has its own atom. That electron starts to get excited, and when it starts getting accelerated, it releases electromagnetic waves, and those electromagnetic waves are only caught by the infrared cameras and all these things. So if you see something in a particular color, don't you have imagination like light is falling on it and reflecting red light. No. Light is falling on it, it is getting absorbed by it, and charges will be accelerating and it will emit some spectra. If that spectra is of red color, you will see red. If spectra is of yellow, you will see yellow. So hereafter, when you think something is in a particular color, don't think it is because it is light is hitting, reflecting. That's how you thought up to now. Red means light is hitting, red is getting emitted. No, light energy is hitting me, I am absorbing that radiation. That radiation is creating accelerating charge particle in my body. My body is emitting electromagnetic wave, and you are catching that electromagnetic wave and you are understanding what color you are seeing, and that is the of. We will talk about it in detail sometime if you get time. But now you understand that electromagnetic waves are produced by the accelerating charged particle. This question comes directly in the examination. Okay, MCQ again. Next, let us try to understand the next concept and give the heading as the concept of displacement current. Give the heading as concept of displacement current. Important topic for the school examination, rarely asked in board exam, but still sometimes asked. But in school exam, for sure it will be asked. Please pay attention. So, if I ask you to recall what is Ampere's circuital law, what will you say? Integral of B dot dl is equal to mu naught of I, that is enclosed, isn't it? Enclosed by whom? Enclosed by Amperian loop. So what did Ampere's circuital law said? It said that if you have a current carrying conductor and if you are enclosing by a loop called as what loop? Amperian loop, then the integral of B dot dl will become equal to mu naught times the current enclosed by it. Suppose current is I, then how much ever current is I, then how much ever the current is enclosed by this loop, you can find the magnetic field here. And you put the equation, you will get the value as mu naught I by 2 pi r in this case. I have derived also, you can check. If this is r and I put the formula of B, it will become B into integral of dl is equal to mu naught times current is I, integral of dl will become 2 pi r. So B will become equal to mu naught I by 2 pi r. This we have done in the previous chapter, if you remember. Yeah, sorry. This we have done in the chapter number 4. You remember this or not? So this was the concept of Amperian loop. Amperian loop said that if you have any current carrying conductor, you draw an Amperian loop, and by that Amperian loop you can find what is the magnetic field at a particular point. That's what Amperian loop said. Now what experiment Maxwell did? This was the experiment of Maxwell, okay? This is Maxwell's experiment. What did he do? He took a capacitor and connected the capacitor with a battery. Okay. If you know how the capacitor works, the moment you connect in the battery, it starts getting charged. If it is positive, it is negative, it starts getting what charged? Positively charged, it starts getting negatively charged, isn't it? So there is a flow of current and it goes like this. That's how the current flows inside a circuit. What did Maxwell do? He kept a compass here. Please pay attention. Magnetic compass. He kept a compass here and he kept a compass here. And he checked whether compass is deflecting or not deflecting. It deflected here, it deflected here, it also deflected here.
But here capacitor inside the capacitor current would be 0.
That's what the doubt was. He told that if I enclose my wire with an Amperian loop, current is enclosed here, so magnetic field will be there. That's what law says. If I enclose the Amperian loop here, yes, current is enclosed, current magnetic field will be there. But if I make a Amperian loop here, there is no current enclosed. Then how is magnetic field coming? Are you getting my point? If I am enclosing Amperian loop here and I am getting a magnetic field, this is justified because he told that integral of B dot dl will give mu naught n times of I. So whenever there is a current enclosed, magnetic field will be there. But we were able to see the magnetic field also when there was no current, and this was the point of worry. It means that Ampere's circular law is inconsistent. Why inconsistent? Because something is missing there. If not missing, then it should have no magnetic field here. Ideally, my needle should not deflect here. Why? Because there is no magnetic field as per the Ampere's circular law. But we got, what we got? We got a deflection here. That was the point where Maxwell started thinking something which I am seeing is not working out here. And after that only, he gave a new concept of displacement current, and he even modified the Ampere's circular law, which is called as modified Ampere's circular law. Ampere-Maxwell law, both way you can say. So he added some more points in this experiment. What did he say? Let us understand that. He said that, see, remember the EMI chapter, Faraday's law? What did Faraday said? Faraday said that whenever there is a change in magnetic flux, there is an induced EMF or induced current. Remember this law? Who gave this law? Faraday gave this law. As per Faraday, whenever there is a change in magnetic flux, there is an induced EMF. He thought, Maxwell thought, if changing magnetic flux can produce electric current, induced current, then why can't changing electric flux can produce some current? He concluded that when I current my capacitor, there is no charge initially. Slowly, my capacitor starts getting charged. Plus, minus, slowly it is getting charged. So the electric field is not constant, isn't it? Electric field is changing. Are you getting why it is changing? Because when I connect the battery, initially there is no charge. Then some charge comes, more charge comes, more charge comes, more charge comes. So its electric field also is keep on changing. Do you agree with me or not? So what do we have here? We have varying electric field here. And as varying magnetic field produces induced current, it was told by Maxwell that varying electric field also will produce a current, and he called that current as displacement current. Theoretically, what did Maxwell say? Maxwell said that whenever there is a change in electric flux, it gives rise to current called as displacement current. And how did he find the mathematical expression for it? It's very simple. We know that flux is what? What is flux? We have many formula of that. We can call integral of E dot dl, E dot dA, isn't it? Or we can also call it as Q by epsilon naught. Do you remember this Gauss law? First chapter this is. Either you can call phi as E dot dA or you can call phi as Q by epsilon also, whatever you want to call it. Now from here if you see, phi electric flux is equal to charge by epsilon naught. Can I write from here? See, I am writing this side, please pay attention. I can write epsilon naught into phi E is equal to Q, just rearranging terms. Then I am going to differentiate both sides. So I am going to write epsilon naught into d by dt of phi E is equal to d by dt of Q. What is d by dt of Q? I current. So what I am getting here, this current is equal to epsilon naught into d phi E by dt. This current only was called as what current? Displacement current. And this was found by whom? Maxwell. So Maxwell said that apart from the current flowing in the wire, which he later called as conduction current, we also have a current which is not visible to us but exists. Time varying current, which is called as which current? Displacement current. And then he modified the Ampere circuital law. And what did he write in the modified version of circuital law? He wrote integral of B dot dl is equal to mu naught times, instead of I he wrote IC plus ID. Earlier Ampere told integral of B dot dl is equal to mu naught into I, only current. Which current? Conduction current. He added one more current. What is that? Displacement current. So if further solve, it will become mu naught into IC plus mu naught into what is ID? Just now you solved epsilon naught into d phi E by dt. This is called as modified Ampere's circuital law, also called as Ampere's Maxwell law, whatever you want to call it. This is also called as Ampere-Maxwell law. Is it clear to you? So Maxwell, he solved the inconsistency of the Ampere's law and he gave his own equation which made the Ampere's law consistent. Now you see, here we have only conduction current, no displacement current. Why? Because current is not varying. I mean electric field not varying. Here you have only conduction current, no displacement current, but in the middle there is no conduction current, but what we have? Displacement current we have. That's why we got a deflection in the needle. He just justified that. So why we got deflection? Because current is there. What current is there? Displacement current is there. Why this current came? Because electric field was changing. Why it was changing? Because capacitor was getting charged and electric field was increasing with time. The moment capacitor gets fully charged, no, deflection will stop of the needle, because no current after that. If you have understood this concept, copy it fast.
Sir.
Ask me, please.
Sir, you told that the source of EM wave is accelerating charge particle. So when a charge particle is getting accelerated, then the magnetic field will change. Now, can we speak with respect to this electromagnetic induction also, sir? Like that, what I'm asking is, can EMF produce EM waves?
Can electromagnetic induction produce?
EM waves.
Not alone. See, if you have only magnet, we can produce electromagnetic induction, right? If you have a coil, I have magnet, may the magnet go inside, out, inside, out, we can produce electromagnetic induction. But we cannot produce electromagnetic wave there. What is missing? Electric field is missing. Electromagnetic wave can be produced only if we have both electric field and magnetic field. But if we have a charge moving, it has both electric field also, magnetic field also. That's why I said that accelerating charged particle alone can produce electromagnetic wave, not the electromagnetic induction alone. So electromagnetic induction cannot produce electromagnetic wave. Electromagnetic wave can be produced only by accelerating charged particles. It can be positive, negative, whatever it may be, but it should be accelerating charged particle. Got it? Whatever you want to copy, please copy. I'm giving you a minute, make it fast. Let me know if you are done. Can I go to the next page? Can I go to the next page? Please copy this also fast. This is modified Ampere-Circuital law. Modified Ampere-Circuital.
For the previous slide for just a minute, sir.
Make it fast, Shaktivel. Shaktivel, let me know when you are done.
Okay, sir. I'm done, sir.
Copy it fast, guys. Done. Please make it fast. I'll go to the next topic. So this month your physics test got over for Sunday test. Shall I proceed, guys? Shaktivel?
Yes, sir.
Okay. Now please pay attention. If you see NCERT book, they have given a set of equations called as Maxwell's equation. So basically, Maxwell has compiled all the equations which other people also gave in electrostatics and electromagnetism, and he gave a set of 4 equations. I'll write 4 and I'll explain all 4 to you. Please pay attention. I'll give time for writing. Please pay attention. The first one is Gauss law, which was closed integral of E dot dA is equal to Q by epsilon naught. The second equation was called as Gauss law in magnetism, which you have not learnt. I will tell you now. Integral of B dot dA is equal to 0. How it comes, I will explain you to now. Third equation is called as Faraday's Lens law, which is integral of E dot dl is equal to minus d phi by dt. And fourth one is called as modified Ampere-Circuital law, which we just now studied, which is integral of B dot dl is equal to mu naught into IC plus mu naught into ID, which is what is ID? ID is epsilon naught into d phi E by dt. This was phi b, by the way. Okay. Again I'll repeat everything now. This is called as what? Gauss law in electrostatics. This is called as Gauss law in magnetism. This is called as Faraday Lenz law. Faraday Lenz law, and this is called as modified Ampere's circuital law. Now please pay attention, I will explain one by one all these things to you. Direct questions are coming from here in the board examination. Table will be drawn, match the following. In case study type question it comes, sometimes it comes in MCQ also. So they will give you 4 equations on the left, 4 on the right, and they will ask you match the following, A to B, like that. Are you getting my point? What does this equation speak? This is quite known to you, right? The first one should be known to you, which was told by Gauss. He told that closed integral of E dot dl, or I can say that net flux passing through any enclosed surface is 1 by epsilon naught times the net charge enclosed. Remember this? First chapter. Second was integral of B dot dA is equal to 0. What it means? It means that if you have some magnetic field lines and you draw a closed surface, then the value of B dot dA will always be 0. B dot dA means what? Magnetic flux, right? What is the meaning of B dot dA here? What is E dot dA? Electric flux. What will be B dot dA? Magnetic flux.
The magnetic field is perpendicular to area vector also.
So that's why you are saying it is 0. You are saying not that is the only reason. It can be, see, it can be like this also. No, we have a surface and we have magnetic field going like this. Area it will be like this. Some angle theta is there. Possible, right, Krishna?
Yes, sir.
That is also possible. But how we justify that integral of B dot dA is always 0? I will tell you that. Please pay attention. We will take for example a bar magnet. Okay. How is the magnetic field lines? From north to south, right? It goes like this. Yeah, inside south to north, outside north to south. Do you agree? Now, if I draw any surface, a Gaussian surface, a closed surface. What is the meaning of Gaussian surface? A closed surface. If you see, through this surface, the number of magnetic field lines entering and the magnetic field lines exiting is always same. What is the meaning of flux, by the way? It is how many lines enter, how many lines exit, subtraction of that is called as net flux. I hope you know this. Magnetic flux or electric flux is net electric field lines inside a surface or net magnetic field lines inside a surface. Here the number of magnetic field lines entering and number of magnetic field lines exiting will always be same, and that is why net flux is 0. Same way here, if any surface you take, check how much entering, how much exiting, it will be same. So number of magnetic field lines entering the Gaussian surface and number of magnetic field lines exiting the Gaussian surface is always same. That is why the value of integral of B dot dA is always 0. This comes from last chapter, that is EMI chapter. You studied that induced EMF is equal to minus d phi by dt. Remember this? In the previous chapter you have studied induced EMF is equal to minus d phi by dt, right? What is induced EMF? A kind of voltage. You studied that E is equal to electric field is equal to electric potential by distance, isn't it? Electric field is always equal to what by what? Electric potential by distance. So electric potential can be written as electric field times distance. Yes or no? See here, electric field, a distance. So dimensionally it is correct. Please pay attention, guys. This formula we have learned in second chapter. I told you it will be used in many places. Electric field being equal to electric potential by distance or minus d by dr in vector form. Negative gradient of electric potential is electric field, or electric field is electric potential by distance. So if electric field is electric potential by distance, electric potential must be electric field into distance. So what is here? Electric potential was there. I am writing electric field into distance. That's why I am justifying this law. And finally, this is just now we learnt, that is modified Ampere's circuital law. So all these four things he framed together, and he called these laws as what laws? Maxwell's laws or Maxwell's equations. Is it clear to you? Sometimes they will ask for 2 mark, write the Maxwell's equation. These 4 are being expected. Is it clear? If it is clear to you, please copy it fast. Please copy it fast. AC means, say, complete the statement here. Make it hotter. Seriously. Let me know when you are done. I also told you how the question will come from here. They will directly ask you, write the Maxwell's equations. Some are consistent already. This was consistent, no? We learned that formula in first chapter itself. This formula was not found by anybody, but he told that. And this formula is just Faraday's law, he told in his own way.
Like the relations are not he changed.
He changed in his way. If you see carefully, you will realize that these both are fluxes. And this is a kind of E dot dl, B dot dl. E dot dA, B dot dA. So he made in that form, nothing else. Shall I proceed? Can I proceed? I hope all of you are done. Okay. Now, give the heading as nature of electromagnetic wave. Write a statement first, write that nature of electromagnetic wave is transverse. Nature of electromagnetic wave is transverse. Nature of electromagnetic wave is transverse. Now this was the point of confusion. Just now I told that light is a electromagnetic wave and not a transverse wave. Now also I am sticking to that. Light is electromagnetic, not transverse. But electromagnetic waves have transverse nature. Being a transverse wave is different from having a transverse nature. Understand that first. What is the meaning of transverse nature? Transverse nature means perpendicular to direction of propagation. That's all. So here you saw that this was the direction of propagation. I had my electric field varying like this, which is obviously perpendicular to propagation direction, and I had my magnetic field varying like this, which was once again perpendicular to direction of propagation. Are you able to understand this? This was electric field and this was magnetic field. Since both electric field and magnetic field are perpendicular to direction of propagation, I say that nature of electromagnetic wave is transverse. It is not a transverse wave, it has a transverse nature. Transverse nature means the electric field and magnetic field are perpendicular to direction of what? Propagation. Understand that in your mind. Sometimes in books they have also mentioned, in NCERT also it is mentioned I think, equations of magnetic field and electric field. Here I am taking electric field like this, which is in y direction, and in x direction I am taking the magnetic field. So the equation of electric field will become E naught sine kx minus omega t. You remember 11th standard wave equation. Same way Bx will become equal to what? B naught into sine kx minus omega t. Do you remember what is the meaning of k? Remember from 11th standard, what is k? Propagation constant, good. Its value is?
2 pi by lambda.
Good. K is equal to 2 pi by lambda. It is also called as propagation constant. Propagation constant. Nothing much comes from here, just the equation of waves I have written here. Don't worry much about it. This is the equation of electric field, equation of magnetic field. It shows that they are time varying fields. Electric field is varying with respect to time and magnetic field is also varying with respect to time. E naught and B naught are the values of what? Peak electric field and peak magnetic field. And a sine equation says that it is a oscillating electric field and oscillating magnetic field. Copy this first. Just write it down.
Sir,
Yes, tell me, man.
I have a doubt, sir. In alternating current, we learned between current and voltage there will be phase difference. Will there be any phase difference between electric field and magnetic field, sir?
See, man, the electric current and voltage having some phase difference is because of the AC circuit consisting of some appliances like inductor, capacitor, resistor. Am I right? Like if you have alternating current circuit and we have a resistor alone, then there is no phase difference between electric field and current and EMF. Same way, if you have purely capacitive circuit, there will be a phase difference of 90 degree. Purely inductive circuit, there is a phase difference of 90 degree. LCR circuit, there is a phase difference. So phase difference, understand what is the meaning of that. It is the difference in phase between current and voltage for alternating current circuit. Don't mix both. What we are talking now is not alternating current itself. We are talking about electromagnetic wave, where if I am having oscillating electric field, if I am having oscillating magnetic field and they are combined together, it forms electromagnetic wave. Are you getting my point, Krishna? Don't confuse in both. I have a charge which is oscillating, having some acceleration, it becomes electromagnetic wave. But alternating current is something else. Alternating current is produced by a varying magnetic flux, isn't it? A changing magnetic flux produces alternating EMF and alternating current. Are you understanding, Krishna?
Yes, sir.
Yeah. Actually, it is an XZ plane and this is an XY plane. You can write BXZ actually, and you can write EYXY if you want to write. Because it is an XY plane, this is an YZ plane, XZ plane, isn't it? One more important topic in this chapter is relation between epsilon naught and mu naught. Important. Again, this comes very frequently in the board examination. It comes very frequently in the board examination. Relationship between epsilon naught and mu naught. Yeah, that's what. Same thing. Simple thing. How to derive it? Let us see. You know that 1 by 4 pi epsilon naught is equal to how much?
9 to the power.
I'll give time for writing, please pay attention. You also know that mu naught by 4 pi is how much? Isn't it? Equation 1, equation 2. I'll write 1 by 2. What will happen? 1 by 4 pi epsilon naught divided by mu naught by 4. So it will become 4 pi will go above and mu naught will come down is equal to 9 times 10 to the power 9 divided by 10 to the power minus 7. 4 pi gets cancelled. I am going to get 1 by epsilon naught mu naught is equal to 9 into 10 to the power 16. I can write this as 1 by epsilon naught mu naught is equal to 3 times 10 to the power 8 whole square, which is actually speed of light. So from here I get speed of light square is equal to 1 by epsilon naught into mu naught. So C will become equal to 1 by root of epsilon naught into mu naught. This is the relationship between speed of light, epsilon naught and mu naught. Important for the exam, direct questions comes from here. Again MCQ question directly comes from here. Copy it fast. Ivan, what is happening at school, man? Which topic now? Which chapter?
They started EMW, sir.
Oh, they finished AC, EMI, everything, right?
Yes, sir.
Suddenly they became fast. Okay. Anshul, what is happening at your school?
Sir is teaching chapter 11.
Chapter 11 in the sense dual nature of matter. Yeah, that is chapter name, man. 11th chapter is dual nature of matter and radiation. I think that only he is teaching. Photoelectric effect, huh?
Yes, sir.
Okay. Kirti, I hope he is right.
Yeah, sir.
Yeah. What is happening in Alvin? Who is from Alvin here? What is happening at your school? Ray optics is going on. Okay. Well, Amal? Ray optics finished? Great. What about Wales? Wave optics. Ray optics finished, wave optics going on. Fast. What is happening in Sriniketan? Started. Where they are? In the middle? Mirror formula. Just started, it means. Tiana will be in volume 1, right? Which? Third chapter. Crescent you are, isn't it? He is only Chaitanya. What is happening in Chaitanya? Atom. They finished 12 chapters. That is 12th is going on now. Okay. Crescent? They are going to start atoms. Which school is remaining? Vellamal is remaining. Narayana, you are Chaitanya only, no man? Chaitanya he told, no? Oh, he is different, you are different. What is happening in your class?
Ray optics today.
Okay. Which school is remaining? I think every school I asked. What is happening at your school? Ray optics. Narayana. In Narayana. Tell me. Huh? Completed fully. Full portion. Volume 2. Okay, good. They have directly onto wave optics. Skipped for board exam itself. No. Students are not behaving, so they skipped the chapter. What is this? Okay, fine. Okay, guys. Pratap, please tell me, man, Pratap.
No, sir, you have left any students?
What, Pratap?
No, sir, you said that you have left some students.
Yeah. What is happening at your school?
My school is problems for EMI DC, sir. We are right now going on problems for EMI DC.
EMI and AC.
Yes, sir.
Okay, what about you, Sarukesh? You raised your hand.
Wave optics, sir.
Yeah, your school students are there. They told wave optics. Okay. So, next class we are going to start ray optics. Don't worry about that. Ray optics is a big chapter. I need some extra class. Then only I can cope up your school. Otherwise, they will go very fast than me. Optics, then wave optics, then it will become very simple and fast. Okay. Now with this topic, basically, this is one part of electromagnetic wave. Whatever I taught now, that is the definition of electromagnetic wave, its transverse nature, relation of epsilon naught and C naught, displacement current, modified circuital law, and all the Maxwell equation. All these things are one part of electromagnetic wave. Second part of electromagnetic wave is electromagnetic spectrum. And I have already given some work to you based upon this. Once again I am repeating, in the board examination and also in your school examination, you will get a question from here only in one category. What will be that? Either they will ask you to write the application of the waves, or they will ask you to write the frequency of the wave, or the wavelength of the wave, or the source of the wave. So I said to you, to everybody of you, draw a tabular column. In tabular column, write the wave name, write its source, write its frequency, write its wavelength, and write its applications or uses. If you do this for all the waves, then you can expect a 2-mark question to come from here and you can easily take it. So, you need not to be taught anything in this. No concept is there. Just remembering the things. A radio wave, its frequency, its wavelength, its application, its source. Microwave, its application, its source, its wavelength, its frequency. If you are remembering those things, then one question for sure will come from here in the board exam. 2-mark question will come. You can easily take it. Okay? And another 1-mark, 2-mark may come from whatever I have taught in today's class, especially from the last topic. And a very common question is this also, where they will ask you write the Maxwell equation, or the question may come like write the modified Ampere-Maxwell law, or 1 mark can come define displacement current, or 2 mark can come draw the electromagnetic wave diagram. This is the only possible questions from this chapter. Nothing else can come. If you have still not drawn the chart, please draw it as soon as possible. Next month, first Sunday, I will keep the test and the portion will be volume 1 fully. So be ready for that and please prepare for it from now itself. Okay? Now we can start talking about ray optics. Because that chart, I mean, I don't want to waste my time in that. You can please draw that chart in notebook and remember that. See, if I am a student, I'll just remember it 1 day before the examination. That is me. You can do what you want. Because I don't want to like why to mug up when anyhow I am going to remember it. So I'll wait for the last day. I'll remember and I'll go for the exam because I'll forget if I read before. So your wish. You remember before the exam or remember now. It's completely your freedom. I'm not going to ask question from there now. But question will definitely come from there. I hope you understood what the question can be. The question can be to write the wavelength, frequency, uses or source of a particular wave. Is it clear to you? Sure? Okay, fine. So, let us start the next chapter itself. Just half an hour, I will just give some quick recap of 10th standard, because I know many of you will not be knowing many things about ray optics. So, I am not starting the chapter officially now, but I am just giving some basics of ray optics now. So, all of you just pay attention and let us recall the 10th standard of ray optics, light chapter, because that is the base for this chapter. If you do not remember the 10th standard light chapter, nothing you can do here. So, I will start with asking questions to you. You can reply, right or wrong is secondary, give a try. I will correct it. Okay, first I will check how much you know. The question starts with Mrityunjay. Tell me, what is the difference between real image and virtual image? Whatever you know, you tell me. Real image, virtual image, how are they different from each other? What you know, you say, yeah. After focus, virtual image. Good. Shweta, Shinde. What do you know, you say?
The image formed behind the mirror, it's a virtual image.
Good.
If it's
In front, real, behind. So, this is the mirror. If it is forming here, it is virtual, forming here, it is real, right? Mirror, front, behind, isn't it? Okay, okay, that is good. Vignesh, Varan. Real will be inverted. Okay. Ivan, some light you want to throw on real and virtual image? At least mute and unmute yourself, man. Yeah.
Real image is our image before the mirror.
Okay, enough. Thank you. Kirti, real and virtual image, whatever you know. Yes.
real image can be seen on the screen.
Okay.
And virtual image is not.
Okay, good. Now, with all the inputs that you have given to me, I will explain to you first the meaning of real and virtual image, because without this topic, you cannot start the chapter itself. If you are seeing yourself inside the mirror, what image is that, real or virtual? It's a virtual image. So, first understand that virtual image, why is it called as virtual, you know? Because rays don't really intersect to form the image. If the rays intersect to form the image, it is a real image. If the rays don't intersect, appear to intersect or made to intersect, it's a virtual image. Difficult to understand. In layman's language, if I say, if the image is formed inside the mirror, like you are daily seeing yourself, combing your hair, putting some powder, something. So, that image is actually what image? Virtual image. But if suppose I stand in front of the mirror and I don't see myself, where am I? If I am having in front of me some mirror, I stand, I am not there inside. Possible, huh? Actually possible. If you have what mirror? Concave, convex, both. Why convex mirror cannot form virtual image? So, concave, convex, both mirrors can form virtual image, and real image is formed only by, sorry, so concave only we can have that, yeah, correct, only you told. So, if you have a concave mirror and you start in front of it, until you are between focus and pole, you will not be able to see yourself. Then where will you be? You will be somewhere which can be seen only if you are having a screen. So, if there is a screen placed, you will be seeing yourself on the screen. For example, in the cinema theatres, you have movie projected on a screen, right? What is that image? Real image. So, real images are always obtained on what? on a screen. Projector also is a real image only. But virtual images are obtained inside the mirror itself. If you are seeing inside a mirror or in any reflecting surface, in water you are seeing yourself, virtual image. In spoon you are seeing yourself, virtual image. But if you are not able to see yourself inside the mirror and seeing yourself on a particular surface, on a screen, then that image is a real image. Next thing, some questions I will ask you once again. Yogit, if the object is placed between focus and pole of a concave mirror, where will the image form? What will be its nature? Focus and pole, concave mirror.
Behind the mirror.
Okay.
It will be a virtual image
Very good.
and will be erect.
Okay. Size? Enlarged or diminished?
It will be enlarged.
Okay. I think he is right. Yes, Mr. Yashwant.
Highly enlarged.
Highly enlarged. Not highly enlarged. Okay. Now you tell me, if the object is placed at center of curvature, concave mirror, where will the image form?
At C itself.
At C itself. Its nature.
Same size.
Same size, good. Real inverted or virtual erect? Very good. You are right. Mr. Hari, if the object is between F and C, seeing the diagram, man, okay, not it, that question is not there, yes. Between F and C, where will the image form? Object between F and C, where will the image form? People started dropping, I am asking questions, they are dropping there. Okay, yeah. Yes, Shweta, F and C. No, definitely not enlarged. Then you don't know. Okay, guys. You must be thorough with all the image formations by a concave mirror, convex mirror, then only you can understand the chapter itself. This will not be taught here. Here we will not teach you the image formation at all. You are expected to remember this from a 10th standard. But something I will tell you. See, if I recall a 10th standard, whenever we learn about the image formation, please pay attention. Guys, I will officially start this chapter only in the next class, 12th standard. Whatever I am doing now is recall of 10th standard, which will help you in 12th. So please pay attention. So image formation, there are some rules. What is the first rule? First rule says that if any ray is passing parallel to principal axis, after reflection will pass through where? Second rule is vice versa of this. Second rule says that if any ray is passing through focus, after reflection will become parallel to principal axis. This is called as pole. Here we have center of curvature. Third rule says that if any ray is passing through center of curvature, it will retrace its path. Aware about this? Why? Why not in the focus? Why not somewhere else? Why only in center of curvature?
Because it is going with the normal.
Good. Because any line which is joining the center of curvature with the mirror is called as a normal line. If I go in detail, you should understand that, you know how this image formation took place. First ray came here, at this point I should draw a normal. Angle of incidence, angle of reflection, that's how it has come. So any line which is passing through center of curvature is normal line. Even principal axis is normal line only. And you know very well, if a ray is going like this, angle of incidence, angle of reflection, isn't it? Am I right? This is normal. If the ray goes on normal itself, angle I is 0, angle R also will be 0. Am I right? Same logic. If the ray is going on center of curvature, it is normal incidence. Angle I is 0. What will be angle R? 0. It will come back in the same path. And the fourth rule says that if any ray is making some angle theta with the pole, with the same angle theta it will reflect back. Law of reflection, basic law. Because angle I is equal to angle R. By using these 4 rules of reflection, I can draw the image ray diagrams. And once again, please spare half an hour to 1 hour, go to your 10th standard textbook, if you are not having, down from internet also, and just refer the light chapter, all the ray diagrams. Otherwise, it will become difficult for you in 12th standard. If you are forgetting everything, it is a very difficult time for you. So basically, go open 10th standard book, spend half an hour time, recall all the ray diagrams, all the ray diagrams. I am going to recall it in one diagram itself. So I am going to draw a diagram which will talk about all the image formations, right from infinite. This is focus of curvature, pole. I am going to keep the object in various positions. For example, I am going to keep it in infinite, I am going to give it beyond C, I am going to keep it at C, between C and F, at F, between F and P. These are the various image positions. Basically in 10th standard, for each object position, they will draw a different ray diagram. What I am doing here is, all the object positions, I am drawing a common diagram, okay, to make you understand. So all these are different object positions. If the object is at infinite, image forms at focus, it is real, highly diminished. I cannot say inverted because it is point sized. If the object is beyond C, image will form between C and F, real, inverted, diminished. If the object is at C, image will form at C, real, inverted, same size. If the object is between C and F, image will form beyond C, real, inverted, enlarged. If the object is at F, image will form at infinite, it is real, inverted, highly enlarged. If the object is between F and P, image will form inside the mirror, virtual, erect, enlarged. Now, if you are seeing this diagram, you should realize that if the object is moving from infinite to focus, the image moves from focus to infinite. Do you agree with me? Object infinite, image focus. Object beyond C, image between C and F. Object at C, image at C. Object between C and F, image beyond C. Object at F, image at infinite. So as the object approaches the focus, the image approaches infinite. And object size is same, see the diagram? Image is changing its size. Point sized, diminished, same size, enlarged, highly enlarged. A concave mirror is versatile mirror. It can create any kind of images, diminished, enlarged, same size, highly enlarged, highly diminished, anything it can create. Not only that, it can even create virtual image which is enlarged. It cannot create virtual same size, virtual diminished. Otherwise, all the other possibilities it can create. That's the concave mirror for you. Everything it can create. One more thing I will say, if you have a convex mirror, it looks like this, right? I hope that everybody understands that I cannot keep the object on this side. It's a polished side. Somebody asked me, sir, why we are not keeping object here? It's a polished side, yeah, standing in front of a wall. Polish means what? You take a mirror, a glass, paint. If you paint it, then how I can see? I should see the silver side only, no? Reflective side only, no? Let's remember that we cannot stand here. Object should be always kept where? Somewhere here. So I am keeping at infinite, then somewhere here, somewhere here, somewhere here, like this. I am giving various positions. Wherever you keep the object, anywhere you keep the object, if the object is at infinite, image will form at focus. It is virtual, point sized. I should not say diminished and all, because it is point sized. I should not say erect and all. It is point sized. As the object is approaching the mirror, the image will also approach the mirror and become little bigger, but whatever bigger it becomes, it will not be bigger than what? Object. So it is 2, 3 and 4. So whatever the object position may be, image will always have the same nature: virtual, erect, diminished inside the mirror between P and F. Whereas when it was concave mirror, we had different object positions, image positions, at F, between F and C, at C, beyond C, at infinite, inside the mirror. So many positions are there. But for a convex mirror, we have only one position. What is that? Inside the mirror, diminished, virtual, erect, always same. A question is asked, it has come in the board exam, 12th. You have two mirrors in front of you. One is concave, one is convex. Or the question that I saw was, one is a plane mirror and one is a convex mirror. And a person is running in front of both. Okay? If you are running towards a plane mirror and if you are running towards a convex mirror, both produces virtual image. So in both you will be able to see yourself. In one you will see a same size of you, one you will see a smaller size of you. If it is a plane mirror, it will be same size. Convex mirror, you will have a smaller size. But as you are running towards the mirror, whether the speed of the image will be same as the object speed, greater than object speed, or slower than object speed in both the mirrors. In plane, in convex. Anybody else? Some other answer? Here they say that it is same for both the mirrors. Double.
Sir, plane same, convex it is less, sir.
Convex it is less. Okay. You think it is less. Convex will be less. Plane will be same. Why less? Why you are thinking it is less? I'll come give a chance to you 1 second. Yeah. I'll ask you 1 second. Yeah. So, speed will be? Why speed? What is the relation to size and speed? Small people, so they will run slower. Huh? What is, image in one, it is image, not the real thing. Justification.
Whenever we keep the object, the image will be formed only between focus and pole. So
Actually, you are thinking right. Good. What is your doubt? Doubt. Yeah, what doubt?
I was about to ask how this.
Yeah, I'll explain. Obviously, I'll explain if I'm telling. In the case of plane mirror, if the object is here, image is here, right? Sharon? Object is here, image is here. Object is here, image is here. That is, wherever the object is, the same distance image will be there, right?
Sir, for plane mirror I understand, but for convex.
I'll come and, I'm a teacher, man. I have so many students in front of me. I should explain to everybody, not only to you. So in plane mirror, whatever we have the distances for object, the same distance of image also is there, right? But in the case of convex mirror, my object can vary from where to where? Infinite to pole. Image can vary only from pole to focus. If the image travels in the same speed, it has less space to go. It can come from infinite, 30 meter, 40 meter. But if focal length is 1 centimeter, it can go only 1 centimeter. Are you getting my point? So it must run slow. If it runs in the same speed as the object, it has to come out of the mirror. Are you getting my point? That's why it will be slower. And lesser the focal length, the slower the speed. If it is very small focal length, very slow, ultra slow it will be. And if it is very large focal length, it will be little lesser slower. Are you getting my point? So always remember the answer is slower. Why it is slower? Because the range of distance of images is less for a convex mirror compared to a plane mirror. Okay. So again I am repeating, go and refer a 10th standard notebook, learn all the ray diagrams, learn the mirrors formula. Derivation will be taught in the next class, but learn those things and be ready for all those things. Okay. So I am winding off today's class. I will meet you guys once again in the next class. Till then, take care. Bye-bye.
Thank you, sir.
Yes, yes, yes. You, what is your name?
Abhishek.
You will wait for 2 minutes, okay?
Thank you, sir.
Take care, take care.